Hello, everyone. Welcome back. This is question two from the final practice questions. Let's do it. So let's zoom out a little bit. So, what we need to do here. So, we're gonna be creating scatter plot that illustrates how quarter sales is influenced by age. All right. So, first of all, what I will do to make your life easier, you will just import from the data quarter sales and age right here. I imported right here, and from that point you can easily make this scatter plot, and that will help us determine these answers. So that being said, we So what I did was I went to data and I copied this and I copied age. I copied the age. So all of this I copied these two, and then I went here. I selected all of this, and and um I went to insert scatterplot, and I made the same exact chart that I had here. Uh, as you can see right here, I inputted like the title on the left and the age. I deleted this one because it's not necessary there. And we're gonna go to settings. So double click. So horizontal axis, and then you're gonna activate the title. The title. So we have this axis. That's age. And then vertical axis, that's another title. And that's in, for us, that's the quarterly telesales. Quarterly sales. Yes, let's go. So we have this. You can put it like in, and this one, the age. Okay. Even we can put it like this one. Okay. Maybe you are wondering how we will make the line there. So that's chart. Ba, ba. No. Mhm. I think trade line. That's this. And you gonna select linear. So as you can see, we have right the line here. So it was the under the vertical axis. So we have the line here, and then also we need these equations and values. So right here is the first, but we want to even place, you want to see the R2. All right, so with this, that's a good start. So that's question two. So we have the graph, and then the response variable is quarterly sales. The exponential variable is age. That's this one is true because So responsible variable, that's like the depending part, and then the exponential variable, that's like the okay. So responsive variable, that's the like foundation, and the exponential variable, that's the age in this case, and it's like what can I say it? It's kind of that's the influencing variable. I feel yes, that's the influencing variable. We can say it like this. So for every da, 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 so for every unit of increase in age, the quarterly sale increase by $198.74. All right. What is this number? This number is right here in this equation, and that's the first number. So for every unit of age, quarterly sales gonna increase by this number because this the x is the age. So it's x and y. For this one, for the part two, right here we can see that. So this is just continuing of this question. Uh, da, 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 da. Quarter cell and base of edge, yes. And so when we are making these equations all the time, we are trying to look into the graph, and we're gonna it's all the time like so quarterly sales as the foundation, we're gonna be starting with that. So quarterly sales equals, and then right here we have the 198 times the training hours, that's the age, plus the 1576, the value. And right here, so we're gonna be doing linear regression model. uh, how we can do that? So we will just easily select it, all of this. We will go right here, linear regression. Okay, so it's not gonna be that easy. uh, so it's this by the x, and then this one, no, and output we will put it like right here. All right, I'm not gonna do that because I already have the values right here. But for you guys, the slope of the regression model, so that's this number 198 under the coefficients. Enter the value of intercept of regression equation, so that's this one. I'm gonna all the time like you need to like check like the coefficients because they are asking all the time for it. What are the proportion of variability in quarter cells is explained by the model. So that's this number square. What is the correlation between cells and age? So for that, you will be using correlation function. So you're gonna be like typing in the Excel correl, and then the range, and uh, yeah. So the one range and the other. So one range we have right here the age, the full age you're gonna be putting in the equation there, and then the second column, and it's gonna give you like this number. Uh, what is the predicted quarter sales for customer that has age 51? All right. So for that, we're gonna be using our equation, and we're gonna be saying, all right. So we have 198. So it's like we can do it like equals 198 times then 51 plus 157.6.7, and it's gonna give us this number. With this number, you gonna be continuing in the another question, the question below, because they are asking us what is the residual for the customer that in the previous question, if his quarterly sales were 10,000, da, 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 da. So you will easily just like selecting this minus and this number, so 10,081. We have it. This is our final. This is one what we need to see, what we want to see. And in the last, determine the p-value and conclusion for the h using significant level 10. Okay. So p-value is significant level. Da, 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 da. That's this one because h, and the h is significant predictor of quarterly sales because the p-value is below 5, so we are in our conclusion, uh, h is significant predictor of quarter. So if it's gonna be under if it's gonna be over 5%, h is not a significant h is not significant predictor of quarter sales. All right, guys, that's question number 2.